Let's use linear approximation to evaluate for the function cosine of x. We're trying to figure out cosine of 3.15. So we're going to use that linear approximation formula, definitely a formula to know, f of a plus f prime of a times x minus a. And for this, we're given the function is cosine of x, and we're not told of a value to use for a. A should always be a value that you can plug in without the use of a calculator. So since this is cosine, I'm thinking of values on the unit circle. Like I should know cosine of 0, cosine of pi over 2, cosine of pi over 4, things like that. So I want to pick a value on the unit circle close to 3.15. Well, pi is 3.14159. So we have pi as being a close value to 3.15 since it's 3.14159. It's close enough and it's on the unit circle. So let's use that as our a value. We're going to first plug in f of pi, which is cosine of pi. And cosine of pi from our unit circle, that's the same thing as over at 180, we're to the other side of the circle. The value of cosine is -1 there. Next thing, I'm going to take the derivative and plug in at my a equals pi value. So the derivative of cosine, it's a cofunction. All cofunctions have negative derivatives. So derivative of cosine is negative sine. So we're going to do f prime of pi, which is going to be negative sine of pi. But remember, we're over on that other side of the unit circle. That y value over there, our pi value at pi for sine is going to be 0. Y value is 0 on the other side of that unit circle. And our third step is to write this in our equation. L of x is going to start with f of a, which we said was -1, plus f prime of a, which is 0, times x minus our a is pi. So we're going to find L of 3.15, because that's going to approximate f of 3.15. And this is kind of nice because this 0 makes everything go away. It's approximately still going to be right around -1 at 3.15. You could grab your calculator, type in cosine of 3.15, and see why our answer comes out to be -1, because it is very close to just being -1. And we've proved it using this approximation formula.